as I looked over the review, I think some of these are probably going to be too tough, so we're going to make them quite a bit easier on the test. So for example, number 1, you're probably not going to see anything that tough on the test, but if you do see something like this, let's work up to one that's a little bit hard. So b to the negative 3, if you ever come across a negative exponent, it's illegal. You cannot have a negative exponent, so the remedy is pretty simple. What you're doing when you have an exponent that's negative is you're dividing. So b to the negative 3 is going to equal 1 over b cubed. So hopefully that's a property that is kind of familiar to you. But what if you have b to the negative 1/3? Now that's going to be a little bit different. So same rules apply. You cannot have a negative exponent. So what you do is you remedy that. You're just going to put 1 over b to the 1/3. Okay, now if you morph that, if you write that as a radical, so it's going to be 1 over the cube root of b. You look at that and you don't have enough b's, you can pull some out, so you're kind of done. But hopefully you remember there's a rule that says you cannot have a radical in the denominator. So this is illegal. It's unacceptable to hand in. And we're actually going to go back to this fraction form of the exponent. And we're going to look right here. 1 over b to the 1/3. So b to the 1/3 must be illegal. So I'm going to multiply it by a fancy 1, a kind of a creative 1, a unique 1. And what I intend to have when I'm done is b to the 1. So I want a whole number for an exponent, not a fraction for an exponent. So the question is, what am I going to multiply b to the 1/3 by to have my outcome be b to the 1? And if you remember, like just whole numbers, b squared times b cubed is b to the 2 plus 3. So when you multiply powers, you actually add the exponents. So the question becomes 1/3 plus what number is 1? And your creative 1 is going to be b to the 2/3 on bottom and b to the 2/3 on top. Okay, so now when you multiply your bottoms, you're going to have b to the 1/3 plus 2/3, and that's b to the 3/3, and that's just b to the 1. And then on top, b to the 2/3 times 1 is just b to the 2/3. So that is your answer. Okay, now number 2. Let's change number 2. Number 2, if you can solve this guy, you're going to be in good shape. 16v to the 4th, all of that raised to the 3/2 power. So move number 1, let's express it as a radical. Anytime you've got a fraction for an exponent, what's really going on is some type of radical. So I'm going to take that 16v to the 4th, put it in parentheses. The tricky part, your denominator is going to go right here. That's your index. And then 3 is going to go right there. Alright, now move number 2. Let's factor the 16 into its prime factors. 4 and 4, 2 and 2, 2 and 2. So I'm going to swap, in place of 16, I'm going to write 2 to the 4th, v to the 4th. All of that raised to the 3rd power. Okay, now you need to take that exponent of 3 and you need to distribute it to every factor in the parentheses. So you're going to have 2 to the 4th cubed, and you're going to have v to the 4th cubed. So you are going to have 2 to the 4 times 3, 2 to the 12, v to the 12. Because when you take a power and raise it to another power, you times the exponents. So now your index is 2, so let's see if we have enough build up, we can pull some out. So since it's a square root, how many 2's can we pull out? And we can pull out 2 to the 6th, because there's 6 2's in 12. Goes evenly, nothing left over. V to the 6th. And that is your answer. You're done. Except for you are going to change at the end of the day, if you take 2 to the 6th and express it as 64, that's going to be your best answer. So this is your best answer right here. Alright, number 3. Okay, again, I'm sorry, but that's too hard. Let's do an easier one. Let's do, what if you've got this? Let's do another one of those. If you've got 343 n to the 6th, and if you raise that to the 1/3, okay, now you're gonna do the same thing. So move number 1, let's write it as a radical. So the 1 and the 3, let's put them where they belong. The 3 is going to go right here, and the 1 is going to be the exponent. Exponent of 1 is pretty sweet, because it's really not much work. Okay, 343 n to the 6th, and then 343, let's factor it. It's going to be 7 times 49, that's 7 times 7. So you're going to have the cube root of 7 cubed n to the 6th, and all of that, I guess, is raised to the first power, but there's nothing to do there. So now, your next is 3. How many 7s can we pull out? We can pull 1. How many n's? You can pull 2. Done. That is your answer. Number 4. Okay, number 4. Let's swap this one out for 216 x to the 9th. Now let's do a hard one. Let's raise it to the negative 5/3 power. Alright, so what should bug you is that negative exponent. So move number 1, let's take it to the bottom. You're going to have 1 over 216 x to the 9th. All of that raised to the 5/3. Alright, move number 2. Let's factor 216. So 216, if you divide it by 2, you're going to have 108. Alright, now 108. If you divide that by, let's see, we can divide it by 2. But is there something bigger? If we try 4, if we divide it by 4, 4 and 27 is going to be 108. 4 is going to be 2 and 2. 27 is going to be 9 and 3. And then 3 and 3. So I've got 1, 2, 3, 4, 5. There we go. So you're going to swap out, I'm going to have to move over here. You're going to swap out 216 for 2 cubed, 3 cubed. Alright, x to the 9th and raised to the 5/3. So let's write it as a radical now. Now let's go, still going to be underneath 1. Now I'm going to go 2 cubed, 3 cubed, x to the 9th. Okay, now the 5 and 3. The denominator always is going to be your index, and the numerator is going to be the exponent. Okay, so I need to take that 5 to everything in the parentheses, so it's going to be 2 cubed to the 5th, and 2 cubed to the 5th is going to be 2 to the 3 times 5. So it's going to be 2 to the 15, 3 to the 15, x to the 45. Alright. So now, how many 2's, 3's, and x's can you pull out? 3 looks like it's going to go into 15, 15, and 45 evenly, so there's not going to be any left over. So I'm going to pull out 5, 2 to the 5th, I'm going to pull out 3 to the 5th, and I'm going to pull out x to the 3 goes into 45 15 times. So last move is just to change those to a number. 2 to the 5th times 3 to the 5th is going to be probably a big number. It's going to be 7,000. 776 x to the 15. Alright. Okay, let's look at 5. Okay, 5, let's swap out for this. Let's swap it out. This is an awesome one. 4 through to 49. So no variables. This is just 100% arithmetic. 4 through to 49. Move number 1. Let's prime factor. So that's going to be 7, 7. So now you've got the 4th root of 7 squared. Do you have enough 7s that you can pull some out? And you don't. So you're done. But if you morph this, if you write this as a base and then a fraction for an exponent, it's going to be 2/4. So if you look at it from this perspective, it kind of changes things a lot. 7 to the 2/4. 2/4 you can rewrite as 7 to the 1/2. So 2/4 is 1/2. Now if I change it back, 7 to the 1/2 is the same thing as 7 right there, square root of 7. And you don't even need to write the 2 or the 1. So square root of 7 is your answer. Okay, let's look in place of 6. Let's write this. Let's write x to the 4/5 multiplied by x to the 6/5, and let's call that your expression. X to the 4/5 times x to the 6/5. If you do whole numbers, x squared times x cubed, it's a lot easier. X squared times x cubed equals x to the 2 plus 3, and the big idea is you add them. So it's no different here. It's going to be x to the 4/5 plus 6/5. And since they're common denominators, you just add your numerators. It's going to be x to the 10/5, and x to the 10/5 is the same thing as x squared. Done. Sweet. Okay, the rest of these, let's leave them. 7. Here we go. -3 times the square root of 98 m squared n squared p cubed. So 98, let's bust it up. 98, if I cut that in half, I'm going to get 2 and 49, and then I'm going to get 7 and 7. So move number 1. I'm going to trade 98 for 2 times 7 squared. M squared, n squared, p cubed. Okay, the index is a 2. It's invisible 2. It's a square root. So on the outside, I have got a -3. Alright, now I'm going to go through each element and see if I can pull some out. 2, all I have is one of them, so not enough. He stays there. 7s, I do have enough, and I can pull 1 out, so it's going to be 7 to the 1. M's, I can pull 1 out. N's, I can pull 1 out. P's, I can pull 1 out, but P's, I can only pull a group of 2 out, and there's going to be 1 left over. So my final answer, I multiply everything on the outside, and you're going to get -21 m n p. On the inside, 2p. Done. 8. Okay, now the trick on 8, if it's a multiplication problem, go ahead and multiply those both together first and write them all under one radical. So the outside, the coefficient's -4, and that's just an invisible 1, so times those together and you're going to have a -4. Underneath, 20 times 10 is going to be 200, and x cubed times x cubed is going to be x to the 3 plus 3, so x to the 6. Alright, factor 200, 110, 10 and 10, and then each of the 10s I'm going to go 5 and 2, 5 and 2, 5 and 2. So in place of 200, I am going to write, I'm going to have 5 cubed, 2 cubed, because each 10 is going to give me a 5 and a 2, and I got 3 of them, x to the 6. Okay, it's a square root, so I can pull out, on the outside I'm going to have a -4, multiplied by, I'm going to pull out 1, 5, I'm going to pull out 1, 2, and I'm going to pull out 3 x's. Okay, underneath, let's see, I'm going to have a 5 and a 2, and the x's came evenly, no remainders. So, easy, you're going to have a negative 40 times x cubed times the square root of 10. Done. 9. Okay, now division. The division ones, you can simplify before you begin. So look at your numbers, 2 and 3, the fraction 2/3, can it be simplified any? And your answer is no. 2/3 is in its simplest form, so leave 2/3. Okay, your m's though you can. M squared on top and m squared on bottom. Two of these m's, it looks like this. M squared on top, m. You have two m's on top, you got 4 on the bottom. An m and an m, if you divide m by m, it's 1. So if I divide those m's, I'm going to be left with m squared on bottom. And the same for my n's. One of these n's on bottom is going to divide into one of these on top and give you a 1. There's 3 total. This 1 is going to cancel one of them, so you're going to have 2 left over. Alright, now let's see if we can pull some out. It's a square root. I only have 2 to the 1 and 3 to the 1, so I don't have enough 2's or 3's, but I do have enough n's that some can come out. So on top, I'm going to pull out an n, and on bottom, I'm going to pull out an m, and you're done. Except for there's a rule that says you cannot have a radical on the bottom. So square root of 3, how you're going to get rid of that is you're going to multiply it by a fancy 1. You're going to multiply it by square root of 3 on top and on bottom. So square root of 3 times the square root of 3 is, on bottom you're going to have square root of 9, and on the outside you just have m. And this is sweet because the square root of 9 is a whole number. It's going to be 3, so we're going to have 3m on the bottom. Now on top we're going to have, on the outside n, on the inside 2 times 3 is 6. So that is our final answer. 10. Okay, this one is fair game. This one's pretty good. Same idea. So 4/5 is as simplified as it's going to get. Leave that. So you're going to have 2 times the square root of 4 divided by square root of 5. U cubed on top. 3 of those u's on top are going to cancel 3 on bottom. So on bottom I'm left over with 1u. 1v on bottom is going to cancel some v's on top. Just 1v, I guess. So you're going to have v squared on top. Okay, move number 2. On top I can pull some things out. Square root of 4 is 2. And on the outside I already have a 2, so 2 times 2 is 4. And I'm going to pull a v out, so you're going to have 4v. On the bottom nothing can be pulled out, so you got 5u. So, can't have a radical on the bottom. Now you're going to have to multiply by 1. Your 1 is going to be 5u, square root of 5u. So I'm going to multiply the bottom by square root of 5u, the top by square root of 5u. And on top you're going to have 4v times the square root of 5u. On the bottom you're going to have the square root of 25u squared. So on the bottom you are going to have 25 is a perfect whole number, and u squared is a perfect square. So there we go. Last one, and then the rest is the essay portion. Okay, this is what we love about 11. Your 3 on top and 3 on bottom are going to cancel. So you got square root of 5 divided by square root of 80. And think of this fraction, 5/80ths. If I divide each of those by 5, you're going to have, I think it is 1/16. And now this one's the easiest one so far because they're both perfect. Square root of 1 is just 1, square root of 16 is just 4. Done. Okay, that's it. If you can handle those 11, you're going to be in good shape.